them before I proceed further?
Sure. I'll give you control, and you can take a look. And I think I've asked a good portion of them, or they got answered already. So.
But there are some that I don't think I addressed, but I just want to make sure that I answer all the questions.
Yep, not a problem. Just hang on 1 second. Let me go ahead and give you control. And you should have control again. And you can answer those questions.
Okay. Okay, so I misunderstood the question about licensing earlier. So you were talking, Gary, you were asking about the licensing for the PTS software itself. Yeah, I think that is a sales question. Not very much sure how much it costs. I think it depends on the partnership between the client and us. But of course, there is a cost associated with purchasing this software, and that REPL affirmation file that would cost some money, right?
Yes, about the actual cost of it, because in SA we've got nobody willing to part with the amount of money that we've been quoted for.
Yeah. So, and Praveen asked, this PTS is a MQ-based queue or some scripts written by Netezza? This is product developed in-house here, and this is proprietary how it communicates between PTS to PTS. Does PTS is user-built or recommended disk configuration based on the volume of data flowing from primary to subordinate, or is there a standard setup? So as I mentioned, so minimum configuration is 8 disks, which gives like 3.2 terabytes, a maximum of 10 terabytes. So before even the customers purchase the PTS server, we would look at their requirements. Basically, the sales team would take a look at the requirements and recommend how much disk space they should purchase, and installation team would install accordingly.
Our concern was we just put a box of TF12 down to a telco over here, and we're feeding the CDRs in, which if there's a problem between the primary and the subordinate PTS, then it's possible that amount of space could be filled up exceedingly quickly.
Yeah. But was that a question? Sorry, was that a question, or you just...
No, that's why I was asking, because 3.5 terabytes isn't a great deal when you're looking at TF24 or 36 and the amount of data loaded by a telco over here. And my worry was if PTS lost contact with the secondary PTS, then what happens to the data on disk, and what happens when Netezza can no longer write to the, or send data to the PTS?
Right. If so, that was your next question. So if the PTS fills up completely, it won't allow any update transactions against those replicated databases. So they will fail.
So it's the equivalent of maximum protection under Oracle's replication as well.
Mm-hmm.
Okay.
So, of course, you would have the 3.6 terabytes to 10 terabytes, right? That is meant for just keeping this in sync. So, after you, no matter how big your replicated databases are, once you initialize, there is no need for them to keep any data or transaction logs in there. And you would use PTSs only for like incremental purposes. So you would have to develop scripts to prune log files from the PTS files to make sure that we don't run out of space. Hopefully you don't use, like, you don't load 3.6 terabytes or whatever on an incremental basis.
Yeah.
Okay. Will the PTS be included in some future pure data release in the cabinet? Meaning, you're asking about the appliance itself, Gary?
But my understanding was the PTS is going to be bundled into some release of Netezza in the future, and obviously it's now pure data, so I'm wondering whether pure data will be sold with replication included at no cost.
That I'm not very sure. The software itself and the hardware itself, I'm pretty sure it probably is not going into the appliance cabinet itself anytime soon. But these three components, the host, the disk array, and switch, probably in the next few months or so, they will be pre-configured at a site in, I think, Guadalajara or Rochester, somewhere, so they can be pre-configured before they make it to the customer site. So that probably is going to be done, but probably not in the cabinet itself.
Okay.
Is the master PTS configuration different that PTS for target? So PTS configuration is not, there is not much to it. It's just you create the directories, which of course have to be the same, and there is no other configuration settings. On the PTS server itself. So they should be the same.
I think he's looking more at the data volumes. Is the amount of disk available on the secondary got to be the same as on the first?
Okay. Sorry about that. There is no requirement that I am aware of that they have to be the same. I think you can choose a different configuration at the secondary site, depending on the expected volume and how long you want to retain the transaction logs. I don't believe there is any restriction that they have to be identical, the hardware configuration at least.
Okay, but there's one PTS server per Netezza host, is there not?
Yes.
So in theory, you'd want the same amount of disk space because you wouldn't want the secondary to run out of disk space when the first one begins to get half full.
Yeah, absolutely. So that is the best practice. Again, you would want to have that as same when you are setting up initially anyway, right? I have answered other questions. Can you do the same at table level? No.
The other question I had was about the groom command. When you run a groom on the primary system, will that go through to the secondary?
Yes, groom itself goes because it does not change the data itself. Actually, the replication services guide provides a list of commands, all the SQL commands. What happens when you execute those commands on the master? Will they be replicated over or not? But groom and the statistics, they will make it through. They will be replicated across.
Okay. Can you back up from the secondary, and will the records then be no longer retained on the primary because no backups occurred?
I'm sorry, I missed that. Can you repeat that, please?
If you do a backup, it won't delete any rows. It won't. If you groom a table, it won't get rid of any rows that haven't already been backed up. If you do a backup on the secondary, will the groom clear those rows on the primary?
No, the data flow is only from master to the subordinate.
Yeah, but when you do the backup, as I say, the standard backup command or the NZ reclaim will not reclaim rows that have not already been backed up. So if you were to do a backup on the secondary and then do an NZ reclaim on the primary, will those rows be removed from the primary?
I believe they will be removed from the primary, yes.
Okay.
But I'll make a note of that and I'll confirm that, okay? How much time to upgrade, where to run these commands? Okay. Replication alternate method. Can you go over again? So let me go back there and I'll come back to that, Paulinda. Alright, so replication alternate method. So in this way, what you do is before you start replication, you take a backup of any existing databases that you want to replicate using the nz backup command. You take backups and so those databases you would rename or drop those databases and you create new databases with the same names. Create database name, replication set, add them to the replication set. And next you would use the nz restore command to restore from those backups to these databases, so that as they are being restored, they will be replicated over to the subordinate node. Okay. So if I don't want to do an initial NZ REPL backup and move the files over to the subordinate node and restore it there, I can just restore, and as it's being restored on the master, they will be replicated over. However, while this restore is going on, the master site will be down, meaning those databases probably will be taken down, meaning we don't want other ETL systems to access. So there is some downtime to it. So it is up to us what method we want to use for initializing the subordinate node. Personally, I think if the database sizes are huge, let's say 15 terabytes or 20 terabytes, that cannot fit in the PTS server, and one of the options available is to take NZ REPL backup onto a tape drive or something like that, and physically ship those backups over to the subordinate node and restore. And that can be cumbersome, and that can take time. But if I don't want to do that, you can do this alternate method of taking backup onto a local NAS drive or whatever, SAN drive, and then restore, and that will be restored over the WAN across the subordinate node. I mean, not necessarily this is less painful, but you just have to weigh the options. So I just wanted to throw that this option is also there. Okay, hopefully that answers the question, Palinda. Okay, so far we have seen how to set up replication. We have installed the PTS software. We have created the nodes, master node and subordinate node, and we activated replication. Everything is well and good. And next thing is how to change roles or failover. So for any reason, if you want to take the master down or you want to promote a subordinate to a master role, there are certain things that you need to do. So the first thing for a planned failover, you have to demote the existing master node to a subordinate role, and you do so by executing this command: alter replication node REPL set master name role subordinate. So that demotes the master to a subordinate role. So any transactions in flight, it will wait until those transactions are completed. A final CSN, the commit sequence number, is recorded. So now all the nodes are in a subordinate role. So no update transactions. Next, you can run the PTS recover command. There is an option called equalize wait. So that will make sure that all the transactions are identical, all the transaction logs are identical across the PTS, and the subordinate applies the transactions through the final CSN. And at that time, you can check the system view, replication sync, to make sure that the CSNs are identical as all the transactions have been applied. Now all the subordinates are the same. And you can choose any subordinate that you want to promote to a master role. And you do so by this command: alter replication node REPL set subname role master. And you have to activate that new master. So now whatever it used to be the subordinate node, now it is the master node. So all your ETL or any update transactions have to be executed against the new master. And you can check the status using the status of the nodes using this system view called v_replication_set_node. Okay, you can make sure that replication is running and all the nodes are active. So this is for a planned failover, when all the nodes are active and you have planned it. But in some certain instances, the master goes down and there is no way for you to reach the master node, and time is running out, and you want to run your ETL and ETL transactions, of course. So for unplanned role transfer might be necessary when the master goes down or no longer in communication. So on the subordinate node, you execute the command alter replication node repl set and the existing master node role subordinate override. So this override option allows you to demote the master from a master role to a subordinate role. And you can again run the PTS recover equalize wait, make sure that all the PTSs are in sync. Wait for queued transactions on the subordinates to be processed. So the following the query can be executed to make sure that it doesn't return any records. So this view _v _replication queue length shows if there are any pending transactions. So make sure that there are no pending transactions. And once you're sure that all the transactions have been applied on the subordinate, you promote that subordinate to the master role using the override flag. So that promotes the subordinate to master, and you activate it. However, you are using the override flag, and you are doing this when the master is not available. But when the master becomes available and connects to the network, there can be some transactions that can be executed against those masters, because the fact that it is no longer a master may not have registered there, right? The metadata, corresponding metadata probably may not make it through the master, and before that happens, if there are any update transactions executed against that, then the nodes become out of sync, because there are two masters and two sets of update transactions executed on two different masters. That is called a transaction fork. How to deal with transaction forks? I'm going to talk about that in the slides below. So that is an unplanned role change or failover. System settings and options. There is a system view called _v _replication config that shows the system settings as well as this node's name. To change any config or any parameter, you use set replication parameter name followed by the value. Again, these are all configured and default values, so there is no really reason for to change it except for node name. But if you do, this is how you do it using the set replication command. So these are all the parameters that are available for you. The first one is max apply retries. So on the subordinate node, if any transaction fails for any reason, PTS will try to apply that again. So you can use this max apply retries to restrict or to set the number of times it should retry before it gives up. Okay. The second one is apply retry interval. So it is the interval in milliseconds between each retry for failed transactions on the subordinate. Max commit delta. So this is the seconds between a commit on the master and the corresponding commit on a subordinate. So you can set that I don't want my max commit delta to be more than, 10 minutes. So if it reaches over the 10 minutes, meaning if the system sees that commit has happened on the master but the corresponding commit did not happen in the 10 minutes on the subordinate, you will get an event. It will generate an event. Max log age. It is the maximum retention age in days of log information on the PTS. It can be used by nz-repl prone PTS command. Metadata interval, period in seconds of the metadata refresh cycle. Again, this is only for metadata. It's been configured. I don't see any reason why we should change that. min log space. If the PTS free disk space is lower than this setting, it generates a REPL PTS util exceeded event. Okay, and the default values are there in the replication guide for reference.
We do have
node name. Sure.
We do have a question from Claudio. It says, what is the impact of PTS on Netezza performance?
On the master side, really there is no performance implication, because all we are doing is just keeping a log of all the commit transactions that have been executed. So there is no negative impact on the master side. And on the subordinate side, of course, it is executing these commands. So these transactions are new that are not existing on the subordinate. So one thing is, on the master side, transactions can be executed concurrently. But on the subordinate side, they will be executed sequentially in that sequence order. So there can be subordinate can be a little slow in these transactions because it is doing a sequential order. So that can be a performance impact. But other than that, on the master side, there won't be any negative impact. Any other questions, Mike?
Nope, that's it.
Okay. And the last one, node name is the node name that you would use to designate name for the NPS node. Commit capture interval is the period in milliseconds of the NPS capture agent commit record polling cycle. So that is the interval in which it polls the NPS for any committed transactions. Monitoring. So the replication provides certain system views that we can use to monitor the status of replication. There are two types of system views. One is replicated views, and the other is non-replicated views. So replicated views, wherever you execute on the master or the subordinate, you are going to get the same result. Non-replicated views, it is specific to that NPS host. So you would get different results where you execute that command, where you query this view. So the first view, the replicated view _v_replication node, it will give you the information about all the nodes in the replication set. _v_replication set gives the information, of course, about the replication set. Third one, the _v replication set node gives information about the nodes corresponding to the set. So it has information about final CSNs and stuff like that. Replicated database, of course, lists all the databases that are being replicated from the master to the subordinate. Replication state gives the status of replication. This is what you would for each database. So for each database, you can see what the last CSN number was between master and subordinate, and make sure that they are in sync. And replication sync, of course, shows the CSNs at the global level, not the global level, but the CSNs level for master and subordinate. Non-replicated views, replication config, of course, shows the configuration settings on that particular NPS host. Replication my node shows information about that node where you query this view. Replication commit log shows information about committed transaction. Replication apply log shows information about what transactions have been applied so far. Applied data file log, which is similar. Replication queue length shows the pending transactions in queue. the PTS utilization, replication PTS utilization view shows the utilization statistics of the PTS server. So it shows disk space and other useful information. Replicated transaction form and PG transactions are like a couple of other system views that are useful in monitoring. Okay, and you can get the details of what these views are from all these views in the replication services guide. With replication, we also have new events on the NPS host. We can configure these events so that we can get notified when something happens related to replication on the system. So these are all the new events that are available for us. REPL role change creates an event when there is a change in a role. REPL state change creates an event when there is a status change in replication. REPL PTS error, again, as the name indicates, it generates an event when there is a PTS error. REPL PTS utilization exceeded is an event when fired when the utilization has exceeded that setting that we set in using the what is this? My minimum log space. So if it exceeds that, if the log space falls lower, this particular event is fired. REPL max retry attempts is fired when a particular transaction fails after so many number of attempts. So when you get this event, probably the replication has been suspended on the subordinate, and we have to attend to that. We have to see what transaction has is stuck on the subordinate, and we have to take an appropriate action. REPL delta commit exceeded notifies an event gets fired if the commit delta between master and subordinate exceeds the whatever setting that we gave, and if it when this gets fired, then we can investigate to see why. It could be either a large file that did not make it through, or sorry, it took a long time to make it through. Is there anything that we can change on the network settings to reduce this and stuff like that? REPL multiple master is an important event. So if you get that, then there is a problem in the replication setup. The system detected multiple masters, so you have to, of course, analyze and see if there have been any forks and how to retrieve from that.
Are there's a question. Are the events enabled by default?
I don't think so. They are templates, so you have to create events. So these are typical, like any other NPS events. There are certain events, the underscore NCS events that come with it. Honestly, I'm not very sure, but again, I would double check, and of course you would have to configure even if they are enabled by default to give your own IP address, give your own email address, or execute a command or whatnot, right? So I would double check. But these are
replication occurs at database level. Can you replicate two databases in different directions?
No. So you're saying you have there is only one replication set, and any database that you want to replicate will have to be part of that replication set, and that replication set will be migrated to will be replicated over to all the subordinates.
Okay. Are they looking at multi-master replication in the future?
Possible in the future releases.
Lovely.
But I won't bet on that though.
Okay.
REPL multiple master, REPL conflicting updates, REPL conflicting updates. I think both go hand in hand. When it detects multiple masters, probably there are conflicting updates. So these might indicate a transaction fork. REPL config conflicts. If there is a configuration conflict, that will get fired. REPL missed heartbeat. Again, as the name indicates, if there is a missed heartbeat in the replication, that event gets fired. So there are some other considerations. First thing is NPS function determinism. So as I mentioned earlier, deterministic functions generate the same value no matter whenever you execute that. And non-deterministic functions return a different value every time you execute those functions. So you can use this variable called replication non-determ check to set to a setting either error or warn or ignore. So if NPS detects a non-deterministic function or non-deterministic SQL, depending on the setting, either it can fail, generating an error, or it can warn you, saying that it encountered a non-deterministic function, or just ignore, send that SQL statement over to the subordinate and replicate. So that is, as an architect, that is your decision on what to do in that particular scenario. But this is a global setting, so this will apply to all non-deterministic functions. But by default, it errors out. Pruning the log files, you can use the nz-repl prune PTS command to prune the log files periodically. You can set up a cron job to prune these log files using this command, like nz-repl prune PTS, using the age flag, 30 days more, and remove. So any log files older than 30 days will be removed in this example. But there are, again, many other options available: days, minutes, hours, and stuff, size also. So there are a lot of options available. So you can look at the help file for this nz-repl prune PTS command to see all the options.
We also have another question. First of all, how does the heartbeat work, and when does it check, and how often?
So on the PTS, there is a heartbeat file, right? So that will be checked to see if that is responding. How often that is checked, I'm not very sure, but that should be in milliseconds, I believe. And if that is missed, you will get an event. But when we get to the demo portion, I will show you the heartbeat file that it looks at. How often that is checked, I'm not exactly sure. But I'll try to.
The other question says, how long the connection from the master to the sub can be down without problems?
How long? I'm sorry, can you repeat that question?
Yeah, well, my guess the question is, and they can correct me if I'm wrong, but between the master and the sub, if it loses connection, how long does it wait in those connections?
Between the PTSs or the master and the PTS? Master and the PTS is a dedicated connection, right? So if it loses the connection, that means it is not detecting the heartbeat. So whatever the polling cycle is, which I'm not very sure, it should be very minimal, you will get notified. But if the connection between the PTSs is lost, that is an issue with the WAN. So there is no way to detect that, honestly. But in the sense, if the commit interval is exceeded, you will get an event. So that probably would indicate PTS to PTS communication error. So if your commit delta interval is like 10 minutes or whatever, and if the corresponding commit did not happen on the subordinate, you will get notified. So you can check to see if the WAN connection is lost. Okay. Hopefully I answered that question. So between the PTSs, you can configure the TCP window size to achieve the maximum throughput. So this can be tuned to achieve good performance. So the optimal size of TCP window size is this little formula. Size of the link in megabytes per second into multiplied by round trip delay in seconds. So to increase the read and write buffer values, you can add these following lines to the etc syscontrol.config file. So you would set net.core wmemmax or the read rmemmax to that optimum value in bytes to get the maximum throughput. Again, probably this will be done by the installation team before when they set it up. They will set these things to the right value. Any other questions before I go further and discuss the transaction forks? Okay. So a transaction fork is an error replication state that results when multiple masters execute different update transactions in the replication set starting at a common root transaction. So as I mentioned earlier, so let's say in certain situations, you might end up with multiple masters, and before it gets detected, there can be some transactions executed on both the masters, starting at a common transaction. And there are two branches now of update transactions. So that is the fourth part of it. So it can occur under certain error circumstances such as network error. Tasks may result in transaction forks that must be resolved before replication can be reactivated. So when the system detects a transaction fork, it stops replication. It doesn't proceed further until you resolve that. We can use the nzRepl_fork command to recover from a transaction fork. And the way to do that is you run this command nzRepl_fork -analyze -set. You give the replication set name. The output of this command lists the branches of the fork. I'm going to show an example in the next slide. So from the branches, you can choose which branch to keep and which branch to discard. And once you choose the transaction, the branch that you want to keep, you can run the following command, like the example shown below. nzRepl_fork with the resolve flag. You have to give the source ID to keep, of course, the replication set name and the source ID and the CSN. All this information you can get that from the output of this command nzRepl_fork. So when you run the nzRepl_fork resolve command, the output of this will give you instructions on how to recover from this transaction fork. So here I show an example. So when you this I got from the application services guide, so you can refer to that as well. So when you execute this command, it will say found fork in replication set so and so with the previous transaction, source ID so and CSN. And the first branch is from the source ID whatever node, and it shows you few update transactions that have been executed from that point in time. And the second branch is on the source and whatever the source is, and it shows the transactions that have been executed on that branch, on that node. So there are two branches here, one with the create database sales reg and the other with the drop database test 1 to 3. So it completed fork analysis and it found one fork. So now it is up to us to choose which branch we want to keep. So once we've chosen which branch to keep, in this case we want to keep transactions executed on 20700. You execute this nzRepl_fork again with the resolve flag. You say nzRepl_fork -resolve. I guess if you're running this on 16.241, you give the node ID, repl set, and the source ID to 20700, and you give the commit sequence number 10 from here, 71, and execute the command. So it gives you instructions. So the following replicated databases have proceeded past the transaction fork on a deprecated branch and will need to be recovered before reactivating replication on this node. So it says you have to run the following command in the REPL analyze using the recovery file and fork recovery. I mean, of course, that is just the recovery file name. You can give the subordinate node name, set REPL set, and the database in question. So that will give you an instructions again on what needs to be backed up and what needs to be restored. Most of the time, it will result in backing up from wherever node that you want to keep and restoring on wherever you want to discard it until they are in sync. But I recommend strongly when you encounter, if at all you encounter a transaction fork, we get in touch with support so they can look at the situation and advise the best course of action. But it's just that we can have another set of eyes looking at us when you resolve this. And of course, in the worst case, you might have to just reinitialize this thing. Reinitialize whatever you want to discard. Any questions on that, guys?
There's another question. It says, are there any best practices helping to determine the master is down and we need to workload transfer to the subordinate?
When the master is down, I guess you don't have any option but to move over to the subordinate. Of course, this depends on the requirements of the client requirements and the SLAs, how long they can wait until the master comes back up, and what kind of issue that is. That is for unplanned. For planned, of course, it again depends on the downtime requirements and the SLA requirements and so on, whatnot. But as far as the best practices, I don't have any, but again, this is entirely driven by customers' requirements, SLA requirements and downtime requirements.
Okay, and I guess the question is, what they're really asking is, how do we know the master is down?
When the master is down, meaning let's say NPS is down. So there are multiple NPS events. If one of these events get fired, and if Netezza NZ state is not online, you will get notification from the event.
Okay.
So that is one thing. So there are so many things that can go wrong on the master side that can take the site down, and of course you will get notified if you have enabled these events. Okay, so that is pretty much what replication is all about. We have seen the architecture of a typical replication solution, how to install the replication software, how to enable replication software, how to create replication nodes, how to assign roles, and how to fail over from master to subordinate, and what to do in certain situations in transaction forks. And next step is to look at how to handle failures in some cases. So the first thing, what to do if an NPS node experiences a host failover from host 1 to host 2. So there is nothing that we need to do here. It will be automatically failed over from one host to the secondary host. Any transactions on the master in flight, probably that will get terminated in, again, any appropriate action. This is irrespective of replication, right? Even if you have replication or not, host might fail over from primary to secondary, and whatever action you take, you can take a similar action. And on the subordinate, let's say if it is in the middle of applying a transaction, and host failover happens, and that transaction might fail, and it will wait until the secondary host comes back up and tries to reapply the transaction. An NPS node experiences a hardware or software failure resulting in temporary inability to process, query, or update transactions. So probably this refers to the question earlier, Mike. So in the initial release, this will be detected by whatever the customer is currently using to detect NPS node failures, meaning events. So this can be a combination of event manager reporting, state transition events, hardware notification events, or any homegrown solutions. I have seen many instances where they have custom ticketing systems like HP OpenView or whatnot, so they can get paged when something happens. There will be no additional detection or automated recovery abilities added in replication as part of replication. In future releases, we may add a central or distributed replication manager that pulls the various replication system components and reports on failures in some automated way. But right now, there is no such capability. So to resolve this, the customers will have an option of resolving the problem to bring the NPS node back online, or in the case of NPS node being a master, manually modifying using the provided management commands. So section 166 refers to the replication services guide. The replication set configuration to demote the old master or bring up a new master, which we have seen earlier how to do that. Future replication releases may try to automate the failover of a node, but not at the moment. The replication capture or apply agent on an NPS master node fails, resulting in the inability to replicate transactions. So if replication capture or apply agent fails, the processes will be managed by the local startup server. So if the startup server fails, that will detect the problem and restart the NPS. No new policies have been developed for this. So that is part of the startup server, and whatever policies are for the startup server apply to this capture and apply agents as well. An NPS node is unable to write to or read from the PTS, whether due to connectivity issues or hardware software issues with the local PTS component. So when this happens, the capture and apply agent will receive an error from the API call when it attempts to read-write transaction or fetch the latest metadata information. And in such situations, a REPL PTS error will be reported by the event manager. So to resolve that, all update transactions on masters will fail until this issue is resolved. And on both a master and subordinate replications is effectively blocked until the problem is resolved. All query transactions, meaning read-only transactions, will continue to work properly. So either the user can resolve the issue and replication will automatically resume, or in the case of a master, the user can manually fail over to a new master on a subnet that does not have the connectivity or PTS related issues. But of course, you have to triage this situation to see where it fares to take the appropriate action if there have been any transactions that have not been replicated over and stuff like that. So you have to analyze that and take the appropriate action in such situations. A communication failure between PTS components. This will be almost completely dependent on the PTS implementation being used for any given installation. The only feedback that NPS layer will be able to see by querying the metadata is that subordinate nodes are falling further behind the master with every passing transaction. So that is the commit delta that I was talking about. So this will be highly dependent on the PTS implementation being used, whatever the connections that we have in the customer's network. May be resolved by local IT personnel resolving network issues. An administrator may decide to temporarily suspend replication on the master node to avoid building up backlogs on the unprocessed transactions. So that is best practices or the SLA requirements, stuff like that. So if they can afford, they can suspend transactions on the master. A heartbeat metadata message is sent every 30 seconds. So probably that answers earlier question on how often this is checked, every 30 seconds. So a missed heartbeat event will be generated if no heartbeat is received for 150 seconds or the latency between the PTS nodes is greater than 10 seconds. Okay, so that is what needs to be done in such an event. A node's data is damaged or corrupted. Okay, so this is detected using normal NPS detection and reporting of this condition are sufficient and will continue unchanged. So once the NPS node is back up and running, you can use NZ REPL backup and NZ REPL restore to restore from a set of synchronized backups. So it is pretty much similar to initializing a new member node. The backups must be recent enough that the intervening transactions can be replayed from the PTS. So if this is not possible, a new set of synchronized backups must be taken if the data becomes corruptible. That is, PTS machine's data is irreparably damaged or corrupted for any reason. So a number of conditions might indicate this. The machine refuses to boot any longer. OS reports error reading from the partition where PTS is installed. PTS daemon refuses to run without errors or exceptions. So all this indicates a PTS issue. So to resolve that, the PTS machine needs to be reinitialized or a new one, and its contents resynchronized from other PTS machines. Okay, so in some cases you can potentially get away with not using NZ REPL backup and NZ REPL analyze, and if the transaction logs are available in other PTS machines, you can use that NZ equalize weight, and the transactions will be captured on the PTS in question. So the corresponding NPS node, if the current master, it needs to be demoted to subordinate, and it must be restored from a set of synchronized backups, since committed transactions may have been lost. Failed transaction application on subordinate node. So when that happens, a REPL max retry attempts event will be detected by apply agent and reported using with the event manager after the configured number of retries has been exhausted. So if the transaction fails even after those number of retries, it will generate that event. Configuration metadata will be updated to reflect that replication on the subordinate node is suspended. So you will get notified. So the user must modify the database to allow completion of the transaction, assuming that the failure was configuration or data related. So the user could also, with the help of customer support, update the transaction metadata to force the transaction to be skipped. The replication must be manually reactivated on the subordinate. So of course, so there is some analysis that needs to be done when this situation is detected. Most likely that is related to that particular transaction. So we have to analyze why the transaction failed and take appropriate action. Subordinate node falls too far behind the master such that the next replicated transaction has already been aged out of PTS. So subordinate is falling so far behind that it filled up the PTS and so the next replicated transactions have already been purged out of the PTS. So the apply agent, when requesting the next transaction to apply, it will be informed that the next transaction is no longer available on the PTS. In that situation, replication will be halted, and configuration the metadata for the subordinate will be updated to show that the replication has been suspended. So in that case, since you have lost those update transactions, you have to run the NZ-REPL analyze on the master and restore the subordinate from the synchronized backups. Okay. And once that is done, you can reactivate the subordinate node. Or you can choose to resync the PTS from other PTS servers and then apply, and then eventually, hopefully, it will catch up. But probably you would have to see why the subordinate fell so far behind. So probably, you have to root cause that issue.
A quick question on that.
Mm-hmm.
Can you do a table, supposing you've got an NPS where you're updating mainly one table and that ages out the PTS, can you do a table level backup and restore to fix that problem?
So when you execute that NZ-REPL analyze command, it will give you what needs to be backed up, right? And that can be a table level backup too.
Okay, cool.
Mm-hmm. I think. Unfortunately, I did not do the NZ-REPL backups so far because there are only very few environments where we could do this, and the lab environment, so far I did not get a chance to do that yet. But I know that the NZ backup, we cannot do table level backups. Can we? Yeah, we cannot do table level backups. So I hope the NZ-REPL backup gives an ability to back up only the things that are needed.
Yeah.
Okay. So subordinate is falling behind the master in terms of time and consistency. So the user can monitor the view replication apply log to look at for increasing values of delta between transaction commit time at the master and the corresponding commit on the subordinate. And when this happens, the REPL delta commit exceeded event will be issued when that $max REPL delta is exceeded, and the default is 5 minutes, 60 seconds. Sorry, 60 seconds. Okay. So when this happens, the customer may need to increase the size of their communication pipe between the master and subordinate, or increase in the processing capabilities of the subordinate, or reduce the update load on the master to resolve that issue. So again, we have to see why the subordinate is falling behind and take corresponding action. Attempt to configure a second active master. So the subordinate NPS node will check the latest metadata to determine if there is any active master before allowing the local configuration metadata to be modified to promote itself to the master role. And if this happens, an error will be reported. So to resolve, promotion from subordinate to master will be refused. The old master must be demoted to subordinate role first, and any associated change reflected in the configuration metadata on the PTS before new master can be promoted. So we have seen earlier, so before you promote the subordinate to a master role, you have to check the system views to make sure that the metadata has been propagated properly across all PTSs and all the roles of all the nodes have been registered on all the nodes, and then you can go ahead with promoting a subordinate node. Second master was configured due to race condition or network partitioning. Each NPS node will pull updated metadata at a configuration interval, which is, we have seen there are some default value in there, such as 5 seconds. In general, only a master is allowed to update its own configuration metadata. If a master detects a configuration metadata change specifying another node as master, it will report a REPL multiple master event via the event manager and suspend replication. This should only happen if network partitioning or NPS node failure on the master required configuration changes to be executed on another machine. So this will happen in few this might happen if you use an override flag to promote a subordinate node because you are missing out SLAs and you need to do that. If two masters are ever detected, the problem will be reported via the event manager and replication will be suspended when it detects that master. So the user must modify the metadata to demote one of the masters back to the subordinate and then activate replication again. And a check for conflicting update transactions will also be done. Okay. Conflicting update transactions due to existence of multiple masters. So on reconnection, multiple masters will be detected if you have, of course, used the override flag. And in addition, the PTS will be searched to see if there are two or more next transactions for the same previous transaction. So this is the fork that we discussed earlier. And when this happens, the REPL conflicting updates event will be sent, and you can choose to get notified. So the user must resolve this issue by reverting one of the masters to subordinate and restoring it from a set of synchronized backups. But of course, you can follow the commands that I suggested earlier to recover from a transaction fork, which is nzREPL, recover from fork and so on and so forth. Okay. Conflicting updates to configuration metadata from different nodes. For example, one node could be altering its name while the master is adding a new node with the same name or is removing a given node. So the apply agent checks for such conflicts when it retrieves the metadata updates posted by other nodes. So when this happens, the user must manually rename, drop, or create nodes to resolve the issue. But if you follow the steps in the sequential order, probably you will not run into this issue. And this will happen only if multiple admins are trying to do things at the same time. Attempt to activate replication without proper initialization. When an attempt is made to activate replication on a subordinate node, a check is made to ensure that global data and all replicated databases have been restored from a set of synchronized backups. So the command fails if this is not the case. So you have to do the necessary things to restore to properly initialize node, which means you have to run the nzREPL analyze command and take the nzREPL backup and nzREPL restore. That is your best friend, nzREPL analyze and nzREPL backup and restore. So in for most other issues, that is the solution. So that is pretty much what replication is about. We have seen some scenarios of failure handling, right? So we have seen the architecture of how to install the software, how to activate replication across, and how to analyze any failure scenarios. So that's pretty much what replication is about. Any questions so far? Great. So there are some references I'm giving here. So,
Kieran?
Sorry. Yep.
There's another question. It says, does PTS support relaxed transaction serialization? That is, can I set serialized true equal to true in...
Right. It does support relaxed serialization, but you have to, that is on the master side, right? So you have to be aware of the implications of that when you relax that serialization on the master side and what can happen. But on the subordinate side, anyways, these will be applied in a serialized order. So you have to worry about that setting on the master side. Okay?
Okay.
So the first thing is, so let me take you to the location. You can refer to this replication services guide. What is happening here? So there is this wiki where you can get all this information. Oh shoot. So what is happening here? So they keep moving this stuff. So there is a site where you can get all these replication documentation. That the same site has the replication services guide. Oh, I have this now. So you can get the replication services guide, which gives you very detailed instructions on how to set this up and whatever we have discussed so far. Site prep and specification document that you can refer to for setting up the PTS host and the storage array and stuff like that. And actually that is discussed in the PTS configuration guide, and I don't think that is published yet. That is used by the installation team, but that's a good reference too. Okay. Site prep and specifications again is typical like other TwinFin specifications document, gives you sizing and all that stuff. There is a community called Replication Services Community. Again, this is a restricted location, and I'm not exactly sure who we need to talk to get access to this site, but this gives you all the goodies about related to replication. This has information about this PTS hardware CFR that you can use for ordering all the components required for replication, and it gives you a bunch of other good stuff. So it gives you overview and stuff like that. So it is good to be part of this community. Netezza quick start replication quick start offering, which I'm going to discuss next. So there is a wiki for this. So all the collateral related to that quick start offering can be found in this wiki. So this has customer facing. You can use the slide deck quick start offering. So you can the outside internal slide deck, external facing slide deck, the budget and planning guide, the marketing data sheet, as well as I think it should have the checklist, pre-engagement checklist. Okay, so you can get all this information from this wiki, everything related to the quick start offering. So that is pretty much it for this session. So if you have any questions, refer to the replication guide, and if you still cannot get an answer, reach out to me. I'll try to get an answer for you. Okay. Moving on to the quick start offering. So when the part.
Do we want to go ahead and take another quick 10-minute break?
Yeah, sure.
Okay, when we do that, we can give me control back so I can stop the recording.
Okay.
And then we can do the quick start.
Oops. Come on. What is? Yep. Sorry. All right. I'll be back in 10 minutes.